So today let's talk about orbitals. So orbitals are something that are really pertinent with electrons. You might have noticed that before I shot this video, I did videos on electron configurations, long way and short way. Those are the quicker way of doing this, but I realized I never really did a video on orbitals by themselves. Orbital diagrams, the 3 rules with orbital diagrams, but I never really talked about an orbital. So what an orbital is an orbital essentially is a shape or a space where we think the electron is. So we don't know where electrons are with 100% certainty, and Heisenberg came up with that. So essentially, if we have like this egg, I put something in the egg, and I closed it, the orbital would be this egg. Because again, if I start moving this around, because again, atoms are always moving, electrons are moving, you cannot tell me with 100% certainty where the matchstick is at any given time. And there's a few reasons for this. 1, electrons are small. 2, electrons are very fast. 3, electrons are random in their motion. So not linear, they don't follow a box, they go completely wherever they want. And maybe even the most important one, electrons hate each other. And that, as I grab my little demo, is because they have negative charges. Because they have negative charges, they're going to repel and be as far away from each other as possible, which leads to this orbital. So essentially, we know the electrons inside this balloon, or inside this egg maybe. We don't know 100% where. That's where we need to start using our guesses or try to get it as close as possible. You know what? It might just be saying, hey, it's inside this balloon. We can be a little more specific than that. So, for example, you might have seen growing up or, through your passing kind of this flat model. The flat model is a little misleading for electrons because this implies that electrons and atoms are flat. They're not. And also it kind of implies that they're going to just be circles the whole time. That's not true. Think of it more like a 3-dimensional sphere. The electron, again, can just float and fly wherever it wants inside this sphere. Well, as it turns out, they're not all spheres. Sometimes the shapes get a little crazy. We have some letters that describe these shapes. S, P, D, and F. Those describe the shapes of the orbitals. So instead of it being like egg-shaped, S is kind of like a sphere. So the electrons are inside this balloon somewhere, and we say that's an S. And as we add electrons, we need to add layers. Very similar to how we add layers with Russian dolls, where each one is bigger than the other. Very, very similar. P, orbitals, I kind of think of the P as kind of like a peanut shape, like an unshelled peanut. So the electrons are somewhere inside this shape. And again, there can be different orientations for this. For example, px through the x-axis, left and right, y-axis, up and down. And then even though a lot of you maybe don't work with z-axis as much in math, that's the one going right towards you. So for example, this would be the z-axis. And again, the electron can be somewhere inside these. The orbitals kind of look like 4-leaf clovers, and I'm going to attempt to do that right now. It's not always the easiest thing. And one of my balloons is slowly shrinking, so I have to be a little quick with it. So kind of imagine this like a 4-leaf clover. I'm sorry, my one balloon's a little small, but it's kind of like that, and you can orientate it a little bit differently. Sorry again for that small balloon. And I kind of remember D for donut. And F orbitals are just weird. Like F for funky, that's what my teachers used to say. So you get these like 3-dimensional shapes, right? Again, there's the 4-leaf clovers, just twisting it. That's get a little more complicated. So these areas are caused, again, and why they spread out like this, like why aren't they all circles? Again, electrons hate each other. And they're going to figure out whatever they need to do to get as far away as possible from each other. And they do that, again, with the shelling. Now, I want to show that really quick. So, for example, let's say you have like an electron. It's somewhere in the S. As you're adding electrons, they're going to stack on top of one another. And that's kind of our idea of orbitals.